few minutes. I thought instead of going deep into the reverse stuff, into the remove stuff, I'd give you a bit of a hint for the homework. Now that I realize that it's more complicated, so I'm going to start with 6C, the doubly linked list, and I'm going to implement reverse, but I'm going to reverse the entire thing. So your homework is a little different than that because you only reverse the first so many elements, and you have a singly linked list. But just to get to show you how it's done. So I've started with the following. I've made myself a test case where I've taken that sample list, and I say when I reverse it, this is what it should look like. Ideally, I also want to have a test case where I'm making sure that it works for an empty list and with a list of one element, and I haven't done that yet. But I will. So now the next thing you want to do is you really want to have that before and after diagram, because otherwise I wouldn't know how to begin. So let me get out my pen. So I have a doubly linked list. So I have a pointer to the first and the last one. First one is here, last one is here. Then each of these here has pointers that go like this. Now what do I want to change? I want to make it so to reverse it, I want the first one now to point to the last, and I want the last one to point to the first. And now I want to kind of reverse each of these arrows, so that means this one, instead of going to the next one, I want it to go to the previous one. And this one here, instead of going to the previous one, I want it to go to the next one. And I want to do that for all of them. So let's see if we can figure this out. So I'm going to start with the position here, and I'll keep moving on to the next one, and each time I'm going to make that surgery. So each time I'm going to reroute these two arrows. So if we look at this situation here as a model, what do I have to code? So I have to switch the first and the last. Remember, when you switch something, you can't just say first equals last, last equals first, because then you override one of them. You have to move one of them in a temp. We've had that with the arrays. All right, and now I have a node current equals first. I'm going to not worry about the empty list right this minute. So while current not equals no, right? But actually, no, I probably have to say current equals last because I just switched first and last. Now, normally, if I didn't do surgery, I would just say current.next. But that's not really going to work because I'll be reversing these things. So to be on the safe side, let me save the next. Say is current.next. Now here I'm going to say current.next equals something, current.previous equals something. And then over here, the current.next, I'm going to do next. Let me actually call it saved next. That way it's very clear. So that way I'm going to move from one element to the next. And so notice that each time I'm just careful to save these things. Maybe later on one can do it a little simpler, but right now I'm just going to save everything in sight. So I'm also going to save the previous one. And now let's say, now I have to say current.next equals saved previous, current.previous equals saved next. That would switch the next and the previous, so wouldn't it? Let me look at my picture again. So this here is the next, and I want to have it point to the previous. This is the previous, and I want to have it point to the next. That looks good. All right, well, let's test it. And it worked. Okay, well, that's kind of amazing. So, now when you look at it carefully, you can see that now I can write it a little bit more simply, because the saved previous here I don't actually need. I could, over here, I could say current dot previous the saved next I do need, and over here yeah, so I guess that's as simple as I can get it. Let's make sure that my test case still passes, and it does. So now I would want to make sure that this also works for an empty list. This actually has a pretty good chance of working, because if the list is empty, these are all going to be null, and there's not going to be any work. But it's better to write the test case than to speculate. Project. Where is it? Do we have a size of this thing? Nope. How do you know whether the list is empty? Okay, well, this should work. Oh, has next is false. And it passes, so it works for an empty list. All right, so the important thing is that you make yourself a bunch of test cases, and I strongly recommend that at home you just use JUnit. And just keep on going with this lab. Make yourself, well, I guess you can't keep going with this lab, you have to keep going with the lab that used the singly linked list. Make yourself this before and after diagram. I did it here very, very fast. And it's a little bit sloppy, so you're probably better off drawing this with a little bit more care. Specifically here, where this interesting thing goes on, what I really should have drawn to make this very clear is I should have put the next and previous boxes explicitly. Because it is a little subtle. Because this thing here went here before, and this thing went here. And now what I want is for this thing to go here and for this thing to go there. And you really want to observe exactly how that works. There's no room for guessing or for ambiguity. So draw these diagrams. It works best with two colors. There will be one of these things in the exam where you have to do some rerouting of some links. So go and bring some paper and bring like a black and a red pencil, so so you can draw this diagram. Of course, in the exam, you're not going to have to reroute like a humongous number of links, but you will have to reroute some of them. There was a question back there? What's that? So in order not to give away the answer for the homework, I did this with the doubly linked list. So when you do this at home with a singly linked list, the good news is there's fewer links that you have to reroute. You only have to reroute the next link. There's no previous link. The bad news is that you don't quite have as much context. You yourself will have to establish the references to the previous and the next ones somehow. But it works the same way. The green thing moves forward, except the green thing needs a couple of friends, I think, that also move. All right, well, you have a few more hours to do this.